Hey everybody, this is Bodechon here. We're talking about significant figures today. So before we get into that, we need to review our rounding skills to make sure we know what we're going to do when we actually start rounding to get to the correct significant figure. So remember that if the number is 5 or above, you're going to round up. And if the number is 4 or below, you're going to round down. So I gave you some examples here if we're rounding to the nearest tenth, okay? Here's the example. So 47.26. The nearest tenth is going to be one place after the decimal. And so you're going to be looking at the slot behind it, which is a 6. The 6 is above a 5, so we need to round this 2 up to the 3. If you look at the next one here, you can see the 10th place is a 6. So we're looking one behind it, and it's a 1, which is below a 5, right? It's the 4 below. So we need to round down. In other words, we're going to keep it just the 6 at the end. This one again, the 0 is what we're looking for, but the 8 is behind it. It's above 5, so we're going to round up. So instead of saying 0, we're now going to say 1. And then the very last one, our 3 is the 10th place, so we're looking at the one behind it, the 7, and that one is greater than 5, so we're going to round that 3 up to a 4 right here. All right, now that we've reviewed rounding, let's talk about what is a significant figure. So each of the digits of a number that are used to express it in the required degree to the accuracy, starting from the first non-zero digit. And that may be really confusing to understand. I promise this will make more sense in just a second. But you just have to know everything pretty much is going to be inaccurate in some degree or some form. It's very hard to get things that are exactly accurate in our world because this is not a perfect world. But if you look at some of these numbers, we have 2,500, and this is going to be the least accurate we can get out of these numbers listed here. As we get into our decimals, we are getting more and more accurate the more decimal places that we have, okay? Even though they're zeros, it's still more accurate. So here's some words you're going to need to know. The first one is non-zeros, and that's just any number other than 0. Right? So 1, 2, 3, 4, 5, 6, 7, 8, and 9 are our non-zeros. Leading zeros are any numbers that will start our number chain off. So whether it has a decimal or not, if the first numbers are zeros, those are called leading zeros. And then we have sandwich zeros. And those are zeros that fall in between non-zero numbers. So it's kind of like they've been sandwiched in. And it doesn't matter if there's a decimal or if there's not a decimal, they're still sandwich zeros. And then we have trailing zeros. And trailing zeros happen at the end of our number chain. And this can be with a decimal or without a decimal. As long as the number chain ends with those zeros, those are called trailing zeros. So here's just an example of one number that kind of has them all in place for you. We start off with our leading zeros. And then we're going to have our non-zero digits, the 5, the 8, and the 3. And then we have a sandwiched 0 right here in the middle. And then we end with a trailing 0 at the end. So here's some rules that you need to know when figuring out the correct amount of significant figures to use. First one, all non-zero numbers are significant. So 1 through 9, we count those, okay? Sandwich zeros between non-zero numbers are significant. We are going to be counting our sandwich zeros. Leading zeros are never significant. It doesn't matter if it has a decimal or not. We don't count it, okay? And then trailing zeros are not significant unless there's a decimal. So the zeros at the end, we will not count. Unless there's a decimal, then we will be counting them as a significant figure. So here's some examples of what we just talked about. The non-zero, so if we take 55, there are 2 significant figures there, a 5 and a 5. Sandwich zeros, 201, there are 3 significant figures, the 2, the 0, and the 1. They all count. And 0.007, there's actually only 1 significant figure, and that's a 7. The leading zeros, remember, they do not count. Even if there's a decimal, we will not count those. And then the trailing zeros in the number 600, there's only going to be 1, and that's the 6. We do not count trailing zeros unless there's a decimal. So if you look at this 800.00, there's actually now 5 significant figures there. We're going to count each one of these digits because there is a decimal making these significant because we're getting more and more accurate as we put in those decimals. All right, so let's try a couple and see if we got this. How many significant figures do you see here? Hopefully you said 4. The trailing 0 is going to be counted because we have a decimal place, and sandwich zeros always count. All right, try this one. And it's going to be all 7 digits. Same thing. Sandwich and trailing count because there's a decimal. All right, how many are here? This one may be tricky because I didn't mention anything about exponents yet, but let me just go ahead and say that we do not count the exponents as significant figures. So really, I just need you to look at this number right here, okay? So there's going to be 5. Each one of these digits will count because these are going to be sandwich zeros. All right, how many counts on this one? And hopefully you said 3. These are trailing zeros, and there's no decimal, which means we do not count them. And how about this one? There's going to be 5. Remember, leading zeros do not count ever. So we're really going to start counting at the 2. The sandwich 0 counts. The 8 counts because it's a non-zero. And because this is a decimal, we will count those trailing zeros as well. All right, how about this one? And hopefully you said all 8 digits. We are counting our sandwich 0 and we are counting our trailing zeros because we have a decimal. All right, now when we add and subtract, we're going to round the value of the lowest decimal place or the lowest significant figure in the problem. So I want you guys to try these out. Pause this video, do the math. You can even use a calculator, it's completely fine. And solve these addition problems, and then try to use your significant figures to round to the correct one, okay? All right, let's go ahead and go over it. So in the first one, the lowest sig fig was going to be right here. Notice this is the answer that we get in our calculator, but now we have to make sure we're going down to the lowest significant figure, which is the tens place. So we are right here, and we're going to round down because this is underneath the 5, right? Lower than 5. All right, over here, our first one, the 7,600, has the lowest significant figure, all right? So when we do our math, we're going to end up getting the 10,231, but we need to go ahead and we need to round that down to make sure that we're getting the correct amount of significant figures. All right, try another one. And if you can see, we have a trailing 0 here that doesn't count. So our significant figure is going to be the 7 in this case. So we have 3. So when we do our math, we need to make sure that we include only 3 significant figures, which means that the trailing 0 on the end doesn't count, right? So that's going to be the correct answer. All right, so when we're multiplying or dividing, it's a little bit different than addition and subtraction. This time we're going to use the amount of significant figures from the lowest significant figure value contained in the problem. So look at this example here. You can see that we're multiplying. This one has 3 significant figures, this one has 8, and this one only has 1. Because of that, we need to end our problem regardless of what it says with only 1 significant figure. And this can be crazy because you can look at this and there's a lot of non-zeros in this answer, but we need to make sure that our result only has 1 significant figure. So it's actually going to just end up being 1 million. And that is not as accurate as we would really like it to be all the time, but it's as accurate as we can be with the information that we were provided. So make sure that you're rounding to the correct significant figure when you're multiplying and dividing. So let's try a couple mixed review and see what we can end up getting, okay? So each one, pause the video, try working out the problem, and see what you get as your result, and we'll go over the answer. All right, let's go ahead and try this one. So if you put this one in your calculator, you're going to end up getting this long answer right here, but we need to go ahead and look at our sig figs and round down so you can end up with 0.2 instead of the 47 on the end, okay? All right, let's try the multiplication problem. Go ahead and pause. All right, let's look at our answer. So you can see we have 3 significant figures, and 6. So the lowest one being 3 is a tie, which is completely fine. If we put it in our calculator, this is the answer we're getting. However, we need to make sure we end with only 3 significant figures. So 1, 2, 3, and the rest will be trailing zeros, which do not count. We still need placeholders for these digits. And I want to make sure that we make note of that. I can never just say 294, right? That's, 294. That's not a representation of that large number. We still need placeholders of those trailing zeros to represent the number at hand, okay? All right, try subtraction. Go ahead and pause. Let's check it out. If you put it in your calculator, you're going to end up getting this 39.066. However, we need to go ahead and round to our sig fig, which is going to be 0.7. So we're going to round up because 6 is greater than 5. All right, and then a division problem. Go ahead and pause. All right, let's take a look at it. So put it in your calculator, and you are going to get a very long number, right? Although we do have a decimal. Our first number that we divided was 5 significant figures. The second one was only 3. That means our answer can only contain 3 significant figures. So we need to take this big long number that came out of our calculator, round to those 3 significant figures. So 2, 6, 1 is 3 significant figures. I need to stop there. I do not need any placeholder zeros because if I went ahead and put a decimal and then a 0, that 0 would then be a significant figure because of the decimal. So I cannot add any more. I don't need any more to represent the number placeholder. So we're good. We can stop right there. I hope this was helpful, you guys. Thank you all for watching. Subscribe to see more. Bye, everybody.